In this tutorial, we will show how to implement storage in grid-connect systems. More and more grid-connected PV systems are now equipped with a battery storage. The objective of such hybrid systems may be quite different from case to case. As examples, increased self-consumption to minimize the consumption from the grid in general. Peak shaving, when the injection power is limited by the grid manager, the overload energy could be stored in batteries. Weak grid recovery for ensuring an electricity supply when the grid is falling. In this tutorial, we will use the demo residential system at Geneva, variant VC4, where all the main parameters already have been defined. Click on Storage. First, you have to choose a storage strategy in the drop-down list. PVsyst provides 3 different strategies of storage: self-consumption, peak shaving, weak grid islanding. Each of these strategies have different constraints. Self-consumption and weak grid recovery require the definition of a user's needs hourly profile. Weak grid recovery requires the specification of a grid unavailability hourly profile. Weak grid recovery may accept a reinjection of PV energy into the grid. Peak shaving doesn't involve a user's needs profile. The battery energy will never be used for feeding the grid except with peak shaving. In all these strategies, the battery charging will begin as soon as PV energy is over the user's needs. First, we will start with a self-consumption strategy. The strategy of self-consumption must be defined beforehand. In this tutorial, these parameters are already set. You have to activate. Click on the button Self-consumption. Values are already defined. Click on OK. We can define the storage pack. We keep a generic brand and we select in the drop-down list the first battery module, lithium-ion. The number of batteries is set automatically according to the load profile. You can read below all the information related to your selection. You can define also operating battery temperature. The battery temperature is important for the aging of the battery. An increase of 10 degrees divides the static battery life by a factor of 2. For this tutorial, we let the parameters by default. The message box tells us to define the maximum charging power. Click the tab Self-consumption. PVsyst has set up all the parameters automatically at security values. The battery charging should not be too quick. For lithium-ion batteries, the charge in 1 hour is the minimum reasonable for the lifetime of the battery. This should be limited by the charger maximum power. The eventual excess power energy will be injected into the grid. If this is not desired, the maximum PV power should be able to charge the battery in 3 to 5 hours minimum. Click OK and validate. Run the simulation. After the simulation, click Loss Diagram to visualize the results and the balances of all this energy flux. The energetic flux is divided in 4 groups: energy injected to the grid, the energy solar used by the user, the energy stored in batteries, and the energy from the grid to the user. Now, we will show you peak shaving strategy. Because we already chose the storage system, PVsyst shows us directly peak shaving. In the message box, it asks you to define the grid limitation value. When the injection power is limited by the grid manager, the overload energy could be stored in batteries. For example, enter 5 in the grid power limit. Validate by clicking OK. Run the simulation, click on loss diagram. You can see below the energy flux is divided by 2. There is the direct energy injected to the grid, and there is the energy stored. With this tool, you can avoid wasting energy that was produced when there was too much sunlight. To use this method, you charge up a battery as soon as the solar power hits a certain level, and then use the battery when the solar power drops below that level. The battery only gets charged by solar power, not from the regular power grid. The last tool left is Weak Grid Island. Come back to Storage. Select Weak Grid Island. This option concerns regions where the grid is not reliable. The PV energy is stored in a battery and returned to the user when the grid is off. The storage pack is already set. PVsyst will show us a message to define the grid unavailability profile. Click on Grid Unavailability. You have 2 options to define the profile. The first is defined as random periods, and the second is defined from a file. For this tutorial, we will choose the first one. Next, set the random unavailability parameters. For example, enter 20% for this parameter. Then you have to define minimum duration, maximum duration, number of periods. You can let these parameters by default. Click Set Random. In the unavailability periods, a value table has been generated. It corresponds to the period during which the grid is cut. By clicking on Show Graph, you can show unavailability periods in the graph. Click OK to continue. Run the simulation. Click Loss Diagram. The energy flux is divided in 4 parts. You can see the direct use of the solar energy. There is stored energy from solar energy. There is energy from the grid. And the last is the missing energy.